Hello guys, in this video we're going to familiarize our viewers with a topic known as Pathfinding Visualizer. Well, if you have literally no idea what that means, you don't have to worry. In this video we are going to explain it with a simple project. Now for the readers, we can easily recommend you these 3 books. If you are too lazy to read any book, well, this is the video for you. Now let us get with the introduction, shall we? So guys, I'm Anshumaan E19CSE062 and I'm here with the introduction. So, you guys must be asking what does pathfinding algorithm actually means, right? So it is a simple process by which a computer application finds the shortest path from one point to another, and this fundamental concept of pathfinding is used in many fields like GPS, video games, robotics, logistics, you name it, and more examples can be viewed in the screen. So, before going into main algorithm steps, we have to familiarize ourselves with few concepts. To start off, there are 2 main steps of pathfinding. The first is called graph generation, the second is called pathfinding algorithm. So, what does graph generation actually means? See, there are many methods of doing this graph generation, okay? But one of the most common method is called cell decomposition. So, what does happen here is the entire map is converted into tiny cells, and for example, if we want to travel in a straight line, we let our agent jump from one cell to another in the same direction. So this is one of many methods. And the second step is the pathfinding algorithm itself. Here we create algorithms such that the computer automatically finds the most minimal yet efficient path from the starting point towards the destination. Okay, one of the most common topic in this project is called grids. So what does happen that we convert the entire terrain on which we are going to apply the algorithm, we convert the entire terrain into combinations of latitudes and longitudes, and it creates, with these attributes we help the navigation process. Basically what does happen when the intersection of the latitudes and longitudes, the attributes I mean, we do the navigation process through these attributes. It simply makes our process much more easier. Now, it's not all rainbows and sunshines, you know. Every solution comes with its own set of problems, right? Here it is irregular terrains. For example, if you want to apply our algorithm process in, say, hilly areas, mountainous regions, regular grids are simply not possible in these cases. So what happens that grids can be subdivided into 2 broad categories known as regular grids and irregular grids, and examples of each of them is given on your screen. Now the main thing, the problem statement. See, it's not a new thing, right? We have our own issues with finding the most suitable path through lanes and many rows, intersections, many obstacles, right? It's a simple yet very annoying problem. It happens at a regular basis. So what is our objective, right? As we mentioned earlier, our objective is to make an algorithm through which the computer itself will show you the shortest path from the starting point towards the end. Without any memorizing obstacles which paths to use, the computer will do the job for you. That is our objective, right? To take a simple yet annoying problem and give you an easy solution.
Importance and need of our project. Our project is really important as it provides a relatively simple solution to a very common issue. This project is really handful in finding the best possible routes through many roads or lanes, which solves a very common yet annoying issue people face every day. Additionally, it is a very user friendly, making it easy to use for common people.
Hello everyone, I'm Ravi and I'm here with the Dijkstra algorithm. Now, let us understand the Dijkstra algorithm. This algorithm works on a formula that is f of n is equal to g of n plus h of n, where g of n is the distance traveled from the starting cell and h of n is the estimated distance from a target cell. Let us suppose that s is the starting point and t is the end point where we have to reach. But these are the words which act as the obstacles between our shortest path. As the yeast algorithm starts searching, each time it enters into the neighboring cells and it looks for those cells which have the smallest value of f of n. In this case, these cells have the smallest value of f of n, that's why it starts moving that direction. Now, like this, it will follow those cells whose values of f of n is the lowest. But there is an obstacle, so it can't go in that direction, so it has to go up and down. So, like this, it will follow those cells for which the value of fn is lowest, and it will search for all the possible cells, and at last it will reach to the end point. At the end, by avoiding all the obstacles, it will provide you a shortest path. Now let me show you what I have made. So this is the board. Okay, now let me first run it. So this is how our pathfinding visualization tools look like. So first let me create a random map and let me choose a start point. Suppose it is here. Now let me choose a finish point. Suppose I choose a finish point here. After selecting the A* algorithm, click on the start search. Now you can see that it is finding the shortest path to reach the end point. Now you can see that the yellow lines represent the shortest path from the starting point and the end point by avoiding all the obstacles. So this is how it all works.
Hello, my name is Mohammed Omar Farooq. My enrollment number is E19CSE062. I am studying BTech first year second sem in Bennett University. I am going to tell you about the second algorithm which we use in our pathfinding visualization, and it's Dijkstra's algorithm. So, what is Dijkstra's algorithm? Let's find out. Dijkstra's algorithm. It is the algorithm which finds the shortest possible distance between you and your destination. Here it finds shortest distance using source vertex to all vertex in the graph. This is the trick used by this algorithm. Here it works on 4 rules. They are: rule number 1, it will make sure there are no negative edges. It will set your present place vertices as 0 and all other as infinity. Rule 2, it will relax all the vertices adjacent to the current vertex. Rule 3, it will choose the closest vertex as the next current vertex. And last rule is, until you reach your destination, it will perform rule 2 and 3. Thank you. That's all about the Dijkstra's algorithm.
Future scope. In future, we can improve our project with work upon irregular terrains and apply the algorithm on those regions having irregular grids. That's how we can apply our solution in regions having complex terrains as well. As a part of our project, the new pathfinding algorithm has been designed and implemented. Pathfinding is plotting by a computer application of the shortest route between 2 points. It is a more practical variant on solving mazes. This field of research is basically heavily on Dijkstra algorithm for finding the shortest path on a weighted graph. The part of the project describes about newly designed and developed pathfinding algorithm and implementation of steer behavior which uses this algorithm. The purpose of this classification is to help the developers to identify the complexity of the task before choosing a certain approach.